Hi everyone, welcome to this geometry tutorial video. Today we're going to be working on a skill that we'll need to solve other problems. The skill we'll be looking at is rationalizing the denominator. So to define what that means, let's take a look at a fraction. Rationalizing the denominator means that I only want rational numbers in the denominator. So here's the denominator, and in the denominator here I have square root of 2. So let's recall what a rational number is. A rational number is a number that can be expressed as a ratio of two integers. For example, 3 over 2 or 1.5 is a rational number. It is a number that can be expressed by the ratio of two whole numbers, two integers, 3 over 2. On the other hand, irrational numbers cannot be expressed as a ratio of two integers. Irrational numbers go on forever without repeating. Examples of this are pi. Pi goes on forever without repeating. And also square root of 2 is an example of an irrational number. In fact, any simplified radical is an irrational number. So when we say that we want to rationalize the denominator, we want to remove the radical, remove the square root of 2, and replace it with a rational number. So let's take a look at the steps we can take to do that. So here are our steps. First step here, this is in the case that we only have a radical in the denominator. So if we only have a radical in the denominator, we'll multiply the fraction, this fraction right here, 6 over the square root of 2. We'll multiply that fraction by the radical over the radical. And what I mean by that is square root of 2. We can multiply any number by 1 to get the same number. In this case, we're going to take the square root of 2 over the square root of 2, and that equals 1. Remember, any number divided by itself equals 1, even a radical. And so that's step 1. We've done that. Now what we're going to do, step 2, we're going to multiply the radical through the numerator and simplify if we need to. And in this case, we just have 6 in the numerator, and we have that times the square root of 2. Okay, so we've multiplied square root of 2 through the numerator. Now in step 3, we're going to multiply the radical through the denominator and simplify. So when we have square root of 2 times square root of 2, that really means, let me go ahead and rewrite it this way. I really have the square root of 2 times 2, which of course is the square root of 4. So let's rewrite it that way. 6 square root of 2 over the square root of 4, which we know is a perfect square, and we can take the square root and get an integer out of the square root of 4. So let's go ahead and do that. 6 square root of 2 over square root of 4 is just 2. So we can now simplify the integers in this fraction. 6 divided by 2. 6 divided by 2 is just 3. So our final simplified answer is 3 square root of 2. So we went from 6 over square root of 2 to 3 square root of 2. And you can see now there is nothing, no irrational number in the denominator. We actually just have a 1 in the denominator, if you want to be technical about that. So we have our solution right here. Okay. So now let's look at the example where we have a radical in both the numerator and in the denominator. And what we're going to do is just add one step to the beginning to the steps we just looked at. So let's take a look at these steps. So before we do any multiplication with radicals, what we're going to do is simplify. So let's take a look at this new first step. So if there's a radical in both the numerator and the denominator, we want to simplify the radicals if possible. And what I mean by that, we have to remember properties of radicals. So properties of radicals, if I have a number, two numbers that are raised to the same power, I can combine those terms. They're like terms. So in this case, square root of 3 and square root of 6 are like terms. So let's see how we can combine those terms first to simplify this problem before we multiply any radicals. So let's rewrite this problem. We can really rewrite this as square root of 3 over 6. The whole quantity is square rooted. And in this case, we know that 3 over 6 is really just 1/2. So still we have this whole radical over the entire fraction, square root over 1 over 2. Okay, so now let's go ahead and make this easy on ourselves and rewrite this as two separate radicals again. Square root of 1 over the square root of 2. Now we know that square root of 1 is just 1, so really we have 1 over the square root of 2. Okay, so now we're back to the first type of problem where we only have a radical in the denominator. So let's go to step 2. If there's a radical in the denominator still, which we do, we want to multiply the fraction by the radical over the radical. So we're going to multiply 1 over the square root of 2 by square root of 2 over square root of 2. So we have 1 over square root of 2, and we're going to take square root of 2 over square root of 2, which remember is just really 1 disguised as a fraction with radicals, and rationalize the denominator. So I'm going to, step 3, we're going to multiply the radical through the numerator and simplify. So 1 times square root of 2 is really just square root of 2. And now we have the same case we had for square root of 2 times the square root of 2, which is square root of 4. And it's really, when we simplify square root of 4, we get 2. So we have square root of 2 over 2. Great. Let's look at one last problem. In this case, we still have a radical in both the numerator and in the denominator. But in this case, we can't simplify the radical. We can't simplify 7 over 3. That is not going to give us any simplified fraction. So let's go ahead and start with step 2. We're just going to take square root of 3 over square root of 3. So we can rationalize the denominator. We can remove the radical, replace it with a rational number. So square root of 7 times square root of 3. This is really going to be 7, square root of 7 times 3, all underneath the radical. In the numerator, that's step 3. And then step 4, we're going to multiply the radicals in the denominator together, so 3 times 3. Okay, so in the numerator, we're going to get square root of 21. And in the denominator, we're going to get square root of 9, which we know we can simplify to just 3. So square root of 21 over 3. And let's see if this can be simplified anymore. Can we simplify square root of 21? Well, we know that the factors of 21 are 7 and 3, which we saw actually just right here. And both those are prime numbers, so we can't factor that anymore to factor out any square roots. So this is our final answer. Great, everyone. Now you know how to rationalize the denominator.